All right, let's go over a review of translations. If you look down at the bottom, we have a definition that a translation will slide, shift, or move an image or shape, but it will not change its size, shape, or orientation, meaning that this rectangle that I have right here will translate by moving around the screen somewhere, but it will always be upright like this. It will always be 3 boxes across by 4 boxes tall, and it will never change its size or orientation, meaning it will remain the same. It's just going to move. Now, oftentimes translations may give you a vector, right? And this vector is going to tell you how much you're going to be translating by. And if I look here, I notice that my vector goes down 1, 2, 3, 4, 5, 6 units, so down 6, and over 1, 2, 3 units, so over to the right 3. That means I need to take each of these points and I need to translate them down 6 units and over 3. So if I was to look at my first corner here, let's focus here on the bottom right hand side and let's go down 6 and over 3. So here we are down 1, 2, 3, 4, 5, 6 and over 1, 2, 3. That means my point here, let's call it point A, would become A prime down here. And we would repeat the same steps, 4, 5, 6, 1, 2, 3. And if this was point B, this is where B prime would be, and we would repeat the steps for all of them. So what I'm actually going to do is I'm going to erase those lines real fast because I have a copy of this rectangle already made, and I'm just going to slide it down to its new location based on this vector. Down, whoops, let's select my shape here. Uh-oh. First, let's copy it and paste it. And let's lock this one down so it can't move. So here I have a copy of this rectangle, and I'll move it down 1, 2, 3, 4, 5, 6, and then over 1, 2, 3 units. So this would be its new position based on the vector provided. Now you'll remember that translations are a series of parallel lines. If I was to connect each of the vertices of our rectangle here, corner to corner, corner to corner. Let's go ahead and match them all up here. You see these 4 green lines. All of these green lines right here, they all follow the same vector of down 6 over 3. And because of that, they all have the same slope. And because they all have the same slope, all 4 of these lines are parallel to each other. It's important for us to remember that in translations can be shown by parallel lines. I'll repeat that. Translations can be shown by parallel lines. And that is how we can match up all of our points, right? A to A prime, B to B prime, C to C prime, and D to D prime. And we have parallel lines showing those changes. All right, let's take a look here at rotations, a quick view of rotations. Down at the bottom left-hand side, we see that rotations will turn a shape or an image around a point, but they will not change the image size or shape, right? So you see here we have our original image, ABC, rectangle ABC, and we have A prime, B prime, C prime, D prime, and A double prime, B double prime, C double prime, D double prime. Now, they are all the same rectangle, they are just rotated. They still have the same area, so they take up the same amount of space, and they're both all still rectangles. They are simply rotated around the origin, around this point. If you recall from our other lessons, we have these rotation rules when rotating about the origin. If you want to rotate 180 degrees, you simply take the x and y values and you switch them to make them negative, negative x and negative y. Now we're going to look here at both 90-degree clockwise and 90-degree counterclockwise, because a 90-degree clockwise is going to move everything to the right, or it's going to start a right rotation like the hands of a clock. And then a 90 degrees counterclockwise is going to begin with a left rotation, or going the opposite direction of the hands on the clock. So let's first take a look at how we got from A, B, C, D to A prime, B prime, C prime, D prime. And we notice that they are to the right of the original image, rotating around this point. So since we are moving to the right, and let's actually trace those lines, right? A to A prime, B to B prime, C to C prime, D, draw it up and over here, to D prime. They're all rotating clockwise. So I have a 90-degree clockwise rotation, which means all of my x and y values, the x value and y value rotate. They switch with one another so that y now goes first and x goes second. But remember that the x value is going to be negative now. If I looked at C, point C here is at the order pair of negative 3, 1. That means I need to switch them and make them 1, negative 3, and then do the inverse sign. So 1, positive 3. And if I take a look for my origin, over 1, up 3, I'm here at C prime. And I would do that with all of my points. And this, A prime, B prime, C prime, D prime, is a 90-degree clockwise rotation. Okay, now let me erase some of those lines to clean it up a little bit. Am I going to be able to? We'll leave it, I guess. Now let's take a look at how we get from our original, I'll just change colors here, from the original A, B, C, D to A double prime, B double prime, C double prime, D double prime. And you see this time we're going to the left, counterclockwise, right? Left counterclockwise. From A to A double prime, B to B double prime, C to C double prime, D to D double prime. Right, we're going that left direction. So that means we take our x and y values, again, switch them, but now the y is negative. C here was negative 3, 1, which now we switch them, and it's 1, negative 3, and then we make the first value negative. Negative 1, negative 3, which is how we got to C double prime. So this right here is a 90-degree counter hyphen clockwise rotation. Okay, and that's how we would calculate these out. It's all about rotating around a point. Now, a big takeaway here for us is to recall that anytime we are rotating, we are going around in circular motions, whether it's clockwise or around in circular motions counterclockwise. And I want to emphasize that term, circular motions. We're going in a circle, and we can represent that with these arcs from one point to another using an arc. Rotations can be represented with circles and arcs. Let's take a look here at a review for reflections. You see I have line XY, which can be viewed here, and I have point A, which can be found at 5, negative 3. And let's talk about reflections. A reflection are their mirror images shown across a line of reflection, right? But they do not change shape or size. So that's an important one for us. They do not change shape or size. Now, we see here line YX, and that's telling us that whatever Y is, X is going to be the same. If Y is 0, X is 0, right? If I look here and Y is 1, X is 1. If y is negative 4, x is negative 4, and on and on. Well, my line's a little off there on slope, isn't it? Let's see if we can adjust that slightly. There we go, that's a little better. Now, we want to reflect point A across line XY, and what we're going to do is we're just going to take a look at how many spaces away from the line of reflection point A is. I see I can go diagonally even number of spaces. It looks like 1, 2, 3, 4 spaces away from my line of reflection. So I could go 1, 2, 3, 4 spaces across and get to A prime. And what you'll notice here is that from A to A prime, if you connect them, you get a line, and that line is perpendicular to my line of reflection, meaning that it creates a perfect 90-degree angle. Again, lines of reflection or reflections create perpendicular lines, 90-degree angles. That's going to be important for you. Now let's say instead of going over line XY, maybe I wanted to go over the x-axis. Let me take another line here. I'll do it in blue. And let's put this here to represent the x-axis. Oops, where did we go? All right, just assume that that's the x-axis there. And now let's say we want to take point A, and I'll do it in a different color. Let's do blue. Now here's point A, and I want to go over the x-axis. Well, again, I can count how many spaces away it is. 1, 2, 3, and go 3 spaces across. 1, 2, 3. And I would have A prime right here. Now, if I took a line tool and I connected these, we would see that these create perpendicular lines.